Hello and welcome back. In our last lesson, we started talking about geometric series, and we're going to go further in that today, and I'm going to show you the geometric series test to determine convergence. A geometric sequence is one in which the same number is multiplied to each term to get the next term in the sequence. The number you multiply by is called the common ratio. The nth term of a geometric sequence with the first term of a1 and common ratio r is given by, well, here's the thing. We can define a sequence in a couple different ways. So let me break this down for you. Here's an example. We're going to write an nth term of this sequence in three different ways. So 3, 6, 12, 24, 48. That's our sequence. Well, looking at that, what do you think the common ratio would be? To get from 3 to 6, we multiply by 2. To get from 6 to 12, multiply by 2. We have a common ratio of 2. Well, each of these different ways to write my geometric sequence has r, the common ratio, in it. So let's just put those right in there. 2 to the n, 2 to the n minus 1, and 2 to the n minus 2. A1 asks us for the first term in the series. Well, that's 3. A2 is the second term in the series. That's 6. But it doesn't tell us what a sub 0 is. But we can figure it out because we just have to reverse the common ratio. So 6 divided by 2 is 3. 3 divided by 2 is 3 over 2. Let's run through another one. So we've got 25, 5, 1, 1/5. First, we have to find the common ratio. To go from 25 to 5, we would divide by 5 or multiply by 1/5. To get from 5 to 1, multiply by 1/5, and so on and so forth. We have a common ratio of 1/5. So again, let's just pop those in for all of our r's right now. 1/5 to the n, 1/5 to the n minus 1, 1/5 to the n minus 2. We know what the first term is. We know what a sub 1 is. It's 25. A sub 2 is 5. So to get to a sub 0, we know we have to multiply by 5. With that background, then we're going to jump into the geometric series test. Here we have a geometric series. We know that a geometric series diverges if the common ratio is greater than or equal to 1, because the terms just keep getting bigger and bigger. Now, if the absolute value of the common ratio is between 0 and 1, we actually know what the geometric series converges to. If we add up all of the terms, the infinite number of terms, they add up to this. AR to the k over 1 minus r. And AR to the k is actually just the first term. So if you can remember, first term over 1 minus r. This is really special. For a geometric series, we can know what all the terms add up to. We can't necessarily know that for other kinds of series. So let's put this into practice. It says evaluate the series or state that the series diverges. Here we have a geometric series, and it's in the form of AR to the n, and in that r position is 1/4. Okay, that's less than 1. So this series converges by the geometric series test. And because it's a geometric series, we can actually know what all of the terms add up to. This is when the index is really important. See how it says n equals 0? That's going to define our first term. So our first term is going to be 1/4 to the 0, which is 1. So that means the sum of our geometric series is first term over 1 minus r. And if you want to simplify that, you'd get 4/3. Next one. It doesn't look like a geometric series right now, but I can rewrite this as 3 times 1/4 to the n. And so there's my a and my r to the n. So again, what's in the r position is 1/4. That is less than 1, so I have a series that converges by the geometric series test. I can know the sum of all of the terms by doing first term over 1 minus r. So what's the first term? Well, we're starting at n equals 0. So my first term is going to be 3/4 to the 0, which is 3. So first term over 1 minus r, 3 over 1 minus 1/4. And if you'd like to simplify that, it's 4. To me, this one doesn't look at first glance like a geometric series because of that 2 to the n plus 1 on top. But again, let's see if we can rewrite this to make it look geometric. 2 to the n plus 1, that's the same thing as 2 times 2 to the n. And now you can start to see a geometric series taking place. 2 to the n over 7 to the n is 2/7 to the n. And now we have, once again, our a, r to the n format, where our common ratio is 2/7, which is less than 1, so the series converges by the geometric series test. We know what it converges to, first term over 1 minus r. Check out the index, it's n equals 2 this time. So our first term is 2 to the 2 plus 1 over 7 squared, which is 8/49. So 8/49 over 1 minus 2/7. Wow, when you say it all in English, there's just a lot of words. Okay, if you want to simplify that a little bit, you get 56/245. Oh, lovely. This one is already set up. A, r to the n. R is 4/3. Oh, that's greater than 1. So the series diverges by the nth term test or the geometric series test. And yeah, we're done with that one. Which of the following series converges to 5? Okay, well, let's see here. We've been working with geometric series, and this first one, well, it doesn't look like a geometric series right off the bat. Let's start by using the nth term test. So we're going to take the limit as n approaches infinity of our a sub n term, and that goes to 5. So the series converges to 5, right? No, it does not. As n approaches infinity, the terms approach 5. So this diverges by the nth term test. Because basically at the end of this series, we're going like 5 plus 5 plus 5 and so on. And that series just grows and grows and grows and grows and grows. So no for that one. Second one, let's rewrite that as 4 times 1/5 to the n. So that is a geometric series that converges because we've got r is 1/5 and that is less than 1. The first term, if n equals 0, the first term is 4. So the sum is 4 over 1 minus 1/5, which is 5. Okay, so this is a geometric series that converges to 5. That one's good to go. And what about this third one? Setup is similar to the second one where I can see we can rewrite this as -20 times 1 over negative 3 to the n. This time, our common ratio, is negative. But that's okay, because it's the absolute value of the common ratio that has to be less than 1. So 1/3 is less than 1. First term is 20 over 3, because we're starting at n equals 1. And so we have first term over 1 minus r. Interesting now, because 1 minus r turns into 1 plus 1/3. So we've got 20/3 over 4/3, and guess what that simplifies to? 5 again. So number 3 was kind of a hidden version of it, but go slow and be careful not to be deceived by the terms going to 5 versus the series converging to 5. Thanks so much for being here. See you next time.